and welcome to today's Cosmology segment. Some interesting stories to cover, and if you didn't check out yesterday's Cosmology segment, make sure you check that out. It was absolutely epic. It was like 17 minutes long, and it included some incredible stories. Maybe you didn't even know about the stories. In any case, let's move on with today's Cosmology segment, which has become a regular feature here at the Smash News Network, least busted name in news. All your weather, well, it comes from space. So let's talk cosmology. First, our forum. So at smashomash.com/forum/mission, you can read about our mission. I'm just going to let it scroll quickly. Please feel free to pause the video if you want to read more about our mission. And yes, the word spectroscopy is there. The word ossified is there, as we don't want our beliefs to be ossified. We've recently updated our forum, smashomash.com/forum. And thanks for posting Mary. So we recently put up a new post here in the Grand Solar Minimum thread under the Sun Forum. So if you want to see that, check it out. We put a whole article there as well as links. New graphics showing up there in the Grand Solar Minimum thread. And today we're not going to talk about anything random. We're going to be talking about Cepheus X4, which has some alternate names, and talk about a highly magnetized pulsar. This particular X-ray pulsar has magnetic fields estimated to vary between 3.2 and 3.7 trillion Gauss. Yeah, between 3.2 and 3.7 trillion Gauss. That's a strong field. Anyway, some Indian astronomers did a survey of this, as it had a strong 2018 outburst. And the cyclotron radiation detected elicited what the information is about the magnetic field. So, follow-up observation of the source during its rare outburst would offer us scope for study. Further follow-up observation of the source during its rare outburst would offer us scope for study of spectral variability with source luminosity, variation of magnetic field strength with time, also to probe nature of its accretion column and geometry where cyclotron lines are produced, the astronomers explained. That article is from phys.org in the Astronomy and Space section. If you want to learn more about V490 Cephei, otherwise known as Ginga 2138 plus 56. This is the same object, by the way. And here is the output we're talking about. This burst right here, this is the outburst that they studied. These are the hard X-rays of this object. And we've included some more imagery of it here. Here it is on pan-stars and optical bands D and Z. And how about if we take a look at it on 2MASS? There it is in infrared. You can see it's quite a homogeneous infrared source. It does not show up in ultraviolet on the Galix, but here it is in blue. And there it is in red, quite similar in those color spectra. And again, there it is on pan-stars in two different optical wavelengths. And this is one of the situations that we run into when we have multiple names for things. So V490 Cephei is one of the names of it, as well as, yeah. So it can be confusing if you're not familiar with the naming conventions. Believe it or not, that's the same object. So anyway, here's the astronomy picture of the day, which brings up the idea of stellar associations. So we've got globular clusters, we've got open clusters, and then we've got stellar associations. And this is one of the stellar associations. This is the molecular cloud here in the constellation of Scorpius. Anyway, great imagery of that. It looks like we're looking at probably hydrogen and X-ray and probably infrared light as well from the way the imagery looks. That's my best guess. I don't know if the caption says anything or not. I'm not going to just read the caption. I'm going to move on to talk about stellar association. So we found a great article here on Wiki about stellar association. It's a very loose star cluster, so it's not as tight as a globular cluster or an open cluster. These stars were probably closer together, possibly formed through the same series of processes, and are now moving through space together. So they're just not bound as objects in open clusters and globular clusters are. This is the least tight association of stars. And there's all kinds of different associations you may want to read about on the wiki page. Here's the graphic. And this is actually astrography here. This is actually showing you the location of the sun, which is right here. There's a green crosshair there if you can't see that. And that's showing the location of the sun with respect to all kinds of other objects. So, of course, one of the ones people are very interested in is, of course, the Pleiades and the Taurus-Auriga association. The Hyades cluster is an interesting one as well. And you can find that graphic as well on the wiki article about stellar associations. That's today's Cosmology segment. We hope you enjoyed it. Don't forget to press like and subscribe if you enjoy the content. I've been your host, Dan, a.k.a. smAsho, signing off from the Smash News Network, Least Busted. Name it News.